I'm just going to assume I need to do pretty much all of them.
Yeah.
Alright. Number one, you got blahs. Now it's increasing. Okay. So that's important. What does it mean that it's increasing?
The first derivative is positive.
Okay, what else does it mean? Because we're doing Riemann sum, so we always want to think about what does that mean the graph is doing.
It has a positive slope.
Okay, which means the graph is doing what?
Going up. Oh,
Eh,
I dropped my pen.
You're fine. So yes, in this case, since we're talking about Riemann sums and talking about like overestimates, underestimates, and stuff like that, that means the graph is going up. So let's see. Let R3 be the value of the right Riemann sum. Okay, so right Riemann sum. So draw your increasing graphs. Notice how they don't tell you anything about the second derivative, so you don't know concavity. So you'd want to draw both. Or do we need to actually go with a third? Oh, we have calculators. Okay. So you can graph it and see what kind of concavity it has and stuff like that. So that might be useful. There's a reason they gave you a graphing calculator. They shouldn't really have given a question like this to the graphing calculator, but we can do that real quick. Alright, so graphing calculator. Because the concavity will be important here. I just don't feel like taking a second derivative, so we can just graph it. Alright, so x. I hate having to use the calculator on the screen. You guys all have your actual calculators, right, for the test?
Yeah.
Yeah.
Okay, good. Because using the one on here kind of sucks. So x squared plus x.
Hey, actually, I got 8 of them right. On part A, I just submitted.
Still less than
Who's
Vivek.
tested one?
The 12th. So you got a month minus a day.
Okay.
Alright, we're looking at from what, 2 to 8? So I change the window from 2 to 8. Okay, I don't really care about the y values. Okay. Okay, so window. Okay, now load. Oh, no, apparently it gets really big. Okay. So let's go to 30. And then 2. Okay, it's not too bad. Alright, so I'm assuming you've graphed it and looked at it. So if you do what kind of concavity does this graph have? Is the question. That's going to be the important part.
Okay, Bob.
So it is concave up. So if you have a concave up graph, will a right Riemann sum be an overestimate or an underestimate?
Overestimate.
Why is it an overestimate?
Because, like, if you're going from the right point and you, like, go all the way up to touch the graph and then you go back over, there's always a little bit that's above the graph.
And that's basically right, yeah. Does everybody understand why it's an overestimate, or do I need to share that? Okay. So then how are we going to pick between the 103 and the 216 part?
So I actually like did the right Riemann sum so I could find whatever like the overestimate would be.
You can do that. Problem is it's going to take a lot of time. So I would do the actual integral value.
Yeah, I did that, but that doesn't tell you anything.
You
Because
know if it's an so I got if you do the actual integral value, you get 156. So if it's an overestimate, then the answer for the Riemann sum has to be D.
Oh, I didn't even think about that. Okay.
And if it was an underestimate, it would have to be A.
Oh, okay. I get what you're saying.
Yeah. Now, do I think they would give you an actual question like that? No. The overestimate, underestimate part is a very good thing. I don't think they'd have you actually calculate like a Riemann sum like that and have it down. Not on the calculator section, really. Well, I guess they could, but I don't foresee them doing that. Well, I guess it doesn't really make itself for response anyway. But either way, they might have you write out the Riemann sum. We've seen that before, so that's a possibility where you have to know your intervals and stuff like that. That's going to be something we'll have to actually do. Does everybody understand how to get the answer to be D?
Yes.
Everybody else besides Berrigan.
Do what?
Do you understand how to get to the answer of D now?
Yeah. Get that one right.
Good. So, yeah, okay. Let f be the function blah. It is known that that's there if a midpoint Riemann sum with two intervals of equal length is used to approximate. What is the absolute difference between the approximation? So here it looks like you actually have to do the Riemann sum, which pain in the ass. But remember, your calculator can make it easier. I'll share the calculator on the screen just to make sure you guys see how to do that, if in case you don't remember. Let's see. There we go. All right. So we're going to put it into y equals. Clear that out. Make sure you're in radians. I'm in degrees because I've been doing physics. All right. So sine of x over 4 squared e to the negative x squared. Alright, okay. So once you put it in there, when you go to start doing your Riemann sums and stuff, remember you can call function values in here. So how do we, I'm going to assume everybody remembers how to do a Riemann sum, yes?
For the
Yes.
most part.
Okay, so if we're doing from 0 to, is that pi over 2? We need a midpoint Riemann sum, so what, pi over 4, so pi over 8 will be our first midpoint. So we get, alright, the length of it is, so pi, clear, alpha, pi over 4, bracket. And then now I am able to call the function instead of having to plug that in, parentheses pi divided by 8. So if we do it like that, you do have to be extremely careful. And I'll show you something actually that came up in the Facebook group later. And then our second point will be the y1 of 3 pi over 8.
Why is it pi divided by 4? The end value?
Because that's the width of each rectangle along the bottom. So you're creating two rectangles since it's a midpoint Riemann sum and you're using two of them. The midpoint is pi over 4, so our first one goes from 0 to pi over 4, and the second one goes from pi over 4 to pi over 2. So you can multiply it by each one individually, or you can factor it out and put it out front. Remember, if the base is the same, you can pull that number out front and then just add up all the interior points, which is what I'm doing to make it easier. Does that make sense?
Yeah.
Okay. And you get that answer, and they want to know what is the absolute difference. So you just take their answer and subtract that number. So 0.0223 minus that, take the absolute value of it. So answer being A. Now, like I was saying with the Y1s up here, you do have to be careful. It came across something earlier. Or the Facebook group. So if I wanted to do, like, specifically came up with integral, so we'll do that. So we'll do, not second, clear, math 9. So let's say I want to do just like the integral of that function. No big deal, you guys know how to do that. Great, cool. And then you get dx. Okay, so that's fine. Now what happens on the second part of their free response question, they want you to do like the integral of that function, but they want to multiply it by something. So like times 2x or something like that. So normally we would go, okay, 2x, and then you could do times in some cases. Math, I won't put the times. Let's do math 9. I don't know why I just did that again. I'm really sleepy still. Math 9. 2 to 3 of 2x of So not too bad if you do it that way, but what the mistake that happened, just to make sure we don't ever make that, not really a mistake, but the way we figured out, if we put y1 first, and then people would want to put like parentheses there, and then 2x dx, we would get a much different answer. Does anybody know why we get that different answer? Hopefully they do.
Those are two different things. In the first one, you're multiplying the function by 2x, and in the second one, you're evaluating the function at 2x.
Very good. That is correct. So you do want to be careful with that. Anytime you do your y1 or something like that and then put parentheses in, that is putting that 2x into the function y1 and then doing the integral. To alleviate that, if you ever need to do any of that kind of stuff, you can do 2, 3. It doesn't matter what order you do them in. So you can do like y1, but if you put a times there, and then you can even put parentheses if you want 2x. That'll let the calculator know that you want to do the function times 2x. We'll get that same 0.005 answer. So these two, the bottom one and top one, are the same. But that middle one there, if you don't put a times in between the y1 and the parentheses, you're plugging that into the y1 value. So you do have to be careful. Just don't make those mistakes, kind of thing, just in case you're doing functions and stuff like that. Because I have a sinking suspicion that they will put a relatively difficult function at some point that you're doing some integrals and stuff with, and then changing it up and doing something like that, like multiplying it by that or something. That's something they could be doing. All right, question 3. Let g be the function blah. At what value of x does g attain a relative max? Okay, so how do we determine relative maximums?
Take a derivative of the function, set it equal to 0, and then
I
test
thought it said minimum. This one is minimum. I literally got that point too.
Yeah, so the derivative here is just replace all the t's with x's. This is testing the second part of the fundamental theorem. So it's literally just that function there is the derivative, but x is replacing the t's, because when you take the derivative of the integral, obviously they cancel each other out, and it's a straightforward one. It's not like a negative x or x squared or anything like that, so we don't have to worry about any chain rules when we do take the derivative of that. So you're just looking for where that function, so plug that function in, and then figure out where it goes from positive to negative, which happens at...
Will you explain the whole... Just literally changing all the t's to x's is the derivative of that integral?
Yeah. So you can't forget. So if we use like, what's it, G notation? Is that what they're using for these? Right. Yeah. So remember that if we talk about the integral of g of x, the easiest way to do it, we'll talk about from like...
Writing on your whiteboard?
Yeah, it'll pop up on the thing in a second.
Oh, okay.
So if we do the integral from like a to x, so it's a constant to some variable is kind of the idea there. That will be equal to capital G of x minus capital G of a. And we could obviously switch those and put the variable at the bottom, et cetera, et cetera. Or they could both be variables. We're just focusing on just the one right now. If I go to take the derivative of that with respect to x, of the integral from a to x, g of x, that is equal to the derivative of g of x minus g of a. So the right-hand side we can evaluate very easily. So what is the derivative of capital G of x? Well, in our case, it's lowercase g of x. And what's the derivative of g of a? Anybody know what the derivative of g of a is? Capital G of a.
Not gonna lie, I can't see what you've written, so I don't.
Oh, it's because I have
So
the.
see,
You could have said, "Hey, the calculator's still up."
that's what I
Or-
said.
All I heard you say is, "Hey, will it be on the screen?" And I forgot the calculator was up. I didn't hear you say, so I think you cut out. Sorry, my bad. There you go. Open up in a
Okay,
second. My bad.
what was the question?
What is the derivative of capital G of a?
Lowercase g of a?
Do we agree with Ivy?
Oh, isn't it 0 because it's like a constant or
Oh,
something?
It's a constant,
that's
so yep,
right.
0. So the integral of that is, or the derivative of that integral is that. That's using the second part of our fundamental theorem, at least in our book, it's the second part. It could be different in other books. So if you take the derivative of an integral, basically they cancel each other out. You do have to be mindful of which one's your variable and which one's your constant and things like that. You could switch those around, and then this would be a negative g of x answer. You could have them both being variables. You could have this being like an x squared, which I'm sure we'll encounter as we move through some of these problems. So I'll kind of save that for right now. Does that make sense, Bergen?
Yeah.
And I'm sure some of these will have them in there somewhere. All right, number 4, continuous function is known to be increasing, important. Selected values of f are given, let the Riemann sum blah using 4 subintervals indicate which of the values is true, statements is true. Okay, so doing the Riemann sum shouldn't have been a problem, so you should have been able to get 15.5, I hope, yes?
I didn't know how to do it.
You don't know how to
I
do the
mean,
Riemann?
I know how to draw like left function over thing.
You don't know how to do the actual Riemann sum now?
Well, I mean, I just forgot because I know you're supposed to like you like do the area of the rectangle, so you find your points, you find the difference times the height.
Yeah, that's exactly right.
I just did not do it right.
No problem. All right, so is it 0 to 8 or whatever? Or is it odd intervals? It's 2 to 11. It's weird intervals. 2, 4, 6, 7, 11. Okay, so when we do the areas of our rectangles, obviously it's base times height, so the base of the first one will be 2. I'll get the function value second. Then 4. Sorry, and then 2 again, going crazy. And then 1. And then 4. So the bases of each rectangle, in this case, end up being 2, 2, 1, 4. And then you just plug in their function values, just because that's how high they are. And we're using a left Riemann sum, so we'll use the left numbers to determine their height. So 0.7, 1.1, 1.9, and what was the last one? And then 2.5. And then that'll get you 15.5. Now this is a non-calculator question, so you would have had to do those by hand. Usually on the non-calculator ones, they don't make them decimals like that, but these aren't too bad because it's like 1 times 1.9, 2 times 1.1. It's not the end of the world. This is one that's going to be the most helpful, is the fact that because they only give you two choices, either 13.95 or 15.5. So if you just realize that this is 10, that's basically 12, that's like 14, and that's 15. You don't even actually have to do real numbers because they're so far apart. So you don't have to actually calculate them. Don't forget to do things like that. So because just by looking at it and eyeballing it, it's over 13.95, you can automatically just know it's a C or D at that point. And then because the function is increasing, is a left Riemann sum increase or overestimate or an underestimate?
Underestimate.
Yep. So the answer is C. Is everybody else okay with understanding that increasing, decreasing determines the overestimate, underestimate for the Riemann sum part here?
Yeah.
Okay. And Mr. Rick, you're being awfully quiet. You okay there?
Yeah, I was making my breakfast, but
Huh?
I've been listening.
That's fine. Just making sure. All right, number 5. Oh, I hate these questions. Okay. Okay, so one of the things we want to look at, remember, for the basically for the summation notation of the integral is remember it's always like f of x times d of x or kind of thing. So we would normally write our integral which remember integral just means an infinite sum. Normally it would be like f of x dx. When we go to do our summation, that dx turns to a delta x, and we have a nice little formula for delta x is b minus a over n. I know it's been a while, so you probably forgot that. So in our case, our delta x ends up being the 5 minus 2 over n, so 3 over n. So that leaves me, it has to be either b or d at that point. Does everybody hopefully remember that a little bit?
Not really.
Yeah.
I absolutely did not remember this at all. But
I figured we
I
did like I think
know the formula.
we did maybe a day on this in class because it's not a huge thing. So it's one of those things that like to really remember it and get it, we would have had to spend a decent amount of time on it and do quite a few of them. When it's like one question on the multiple choice, so it wasn't worth the time, to be honest. That part I was hoping you'd remember because that was one of the ways I told you guys you could narrow down the choices is by remembering your delta x being out there. So it's like something times your delta x. So then the other thing we have to remember is that when we're evaluating this, since we were doing what, right, Riemann sums, right? Now we don't know if we're doing a right or a left. Oh, that's a pain in the ass.
I just noticed that your bottom bound has to be your A. So that's why I went with D.
What do you mean your bottom bound has to be your A?
Like the 2 is your A. Because it's A plus delta K, I think, times delta X or something. Or, I don't know. I looked at the formula and then something about that bottom bound of your integral had to be sigma thing or something.
Okay, I see what you're saying. Yeah, that way it would work. Because what you're really doing is you got to think about, and like I said, this is, so we would start, so here, so we would start at 2 and end at like what, 5? So you have to ask yourself, each of these rectangles needs to be how far apart. So this is your delta x, which comes from our formula up there. And then this would be a plus delta x. So we'll do 2. So it'll be 2 plus your delta x is what that is. So that's going to be like your height value. And then your function value. So you got to ask yourself, which one are you using? Are you using a left Riemann sum or a right Riemann sum? And that's kind of the question you got to ask yourself. So if you're doing your right Riemann sum, or left Riemann sum, it's just f of 2. If you're doing your right Riemann sum, which is the one that we typically do, it's going to be this right here. And that's where you're going to really talk about that value being your function evaluated at that. But the thing about it is, well, it starts to become a little bit more difficult, is if you go to the third one, it's 2 plus 2 delta x. And the next one's 2 plus 3 delta x. And I don't know if you can see those numbers. I forget that. I'm writing small. I'm sorry. Each time you go up, you're adding a delta x, which is where that k value that Rudek kind of mentioned comes from. And if you notice, the k value is one that's being incremented each time. So you're adding a delta x each time. So this is the value that you'd be plugging in. You'd plug in this one, and then this one, and then this one, until eventually you get to the very last one. And do your Riemann sum that way. That's the typical way to do the Riemann sums with your sigma notation. So what you're plugging in is going to be f of 2 plus, yeah, you can do that. K delta x times delta x is really what it's going to be in this case. And it just depends on what the inside is, how it'll end up looking. It's kind of a weird thing. But that is a way of looking at it. Again, even this year with everything going on, I doubt you'll even see this. It's highly unlikely. I actually don't even really agree that we should still do it because it's kind of, in my opinion, a little archaic. But it is what it is. Does anything I'm saying make any sense?
Yeah.
Okay. And then when you plug in the 2 plus k delta x into the function, you do get your answer choice of D. And then for 6, okay, so the first thing I would always do, obviously, is identify my function. So this will be like sine squared of something plus 3, which is fortunately what all of them have, so they didn't give us anything there. The 4 over n they made it easy for us. It has to be b. If you look at the inside of your sine squared, that a value being 1 tells you where to start. So your function would start at 1. So the only answer choice there is b.
How do you know it starts at 1?
If you look inside of your sine squared function, it's 1 plus, remember your k delta x? That 1 value is where you started at. If you look at the previous example one I saw on the board, each of those started with 2 plus something. It's 2 plus delta x, then 2 plus 2 delta x, then 3 delta x, and 4. But it's always that 2 value. It has to tell you where to start. So this integral here has to start at 1. And we know it had to be an interval of 4 because we do have a 4 over n. So 1 to 5 is my only options. Does that make sense?
Kinda.
So you want to look, like I said, on here you want to look on the inside of the function. if in order for it to be like, it could have been answer choice C, that would have been an option. However, we can't pull the 4 out in front. So that's definitely not going to be an option. And then I guess D could have. Oh no, D can't be the option because it starts at 0. So I'm not going to lie. These are relatively tricky problems for no ungodly reason, and we don't really need to ever do them. But they're in there. Which of the following could be the Riemann sum for arctan? So the answer choices have to be C or D at this point on number 7, because the 1 to 4. So your delta x is 4 minus 1 over n. So it's got to be C or D. And C would not take into account starting at 1, so it's got to be D. It's going to be, remember, it's going to be 1 plus something. And then back to a real calculus question, number 8. That should be easy. That's just x to the 4th plus x squared plus 1. I don't like their use of dt there. Whoever wrote this problem needs to pay attention better. But everybody should be okay with number 8 after our conversation earlier, I believe, yes?
Yeah, I got that one.
Okay. Number 9. Alright, number 9. The graph F consists of 3 line segments. Okay, so in general, what is h prime? Let's figure that out. Make sure we get that part first.
What was your question?
What do you mean?
What is h prime?
It is
F of t.
x.
F of x. So then what is h prime at 3?
It's
F
just
of
f
3.
of 3.
And f of 3 is
4.
4. Okay, then now looking at number 10, this is where both our bounds A and B have a variable in it. Is that a pi or is that a x? That's a pi.
It's really small.
Yeah, that is. So never mind, only the top one has it. But now when we take the derivative, that top bound not being an x means we have a chain rule. So we do have to be extremely careful with that. So it will be cosecant of sine squared of x to the 4th plus 1, and then times the derivative of sine squared. So it's not terribly hard question because the only answer choice that's even close to that is D. So the answer choice being B, if you look at that one, that is what happens if you don't multiply by the chain rule. So you have to be careful. Actually, no, that's right. So then don't forget you have to multiply by the chain rule if your bound is not just a plain x. It's always a chain rule. So the derivative of sine
But you're
squared
doing
is,
the chain rule of the original of the function, not of the sine squared, but of cosecant.
no, you're doing
That's
the
what you're-
derivative of sine squared.
Oh.
Yeah. So
Okay, got it.
what would happen, or what it would look like. What variable did they use? H, isn't it H?
H of x and then
Okay.
t in the problem.
So h of x being the integral of pi over 4 to sine squared. I'm going to call this f of x just to make my life a lot easier. That, when I do the integral, is equal to capital F, even though I don't ever actually find it, of sine squared x minus capital F of pi over 4. When I go to take the derivatives of these, so d dx of h of x is equal to d dx of that. That's f pi over 4. So derivative of this, chain rule tells me to do the derivative of my outside function, which is f, so it becomes lowercase f of sine squared of x times the derivative of the inside, which is 2 sine x cosine x. And then if you want to write minus 0, minus 0. So that's why you just plug your sine squared x into your function that they gave you and then multiply by its derivative. So multiply by sine squared. Okay, number 11. Select values of the differentiable function h and its continuous first derivative h prime are given. Let f be the integral. What is the least possible number of critical points? Okay, so this is basically an f prime and f double prime table then. So we want to know how many times does f prime hit 0? So how many times does h hit 0? 1, 2? Does that make sense for everybody, or do I need to explain more?
I'm good.
Okay, moving to 12 then. Okay, so how do I tell if g is decreasing?
Has to be negative.
What has to be negative? I believe you said it, so that's a bad word.
The graph.
Why does the graph, and you want to be
why?
careful, I understand what you're saying. The graph, when you said the graph being negative is fine. So why does the graph have to be negative? And we do want to be careful when we do, if we were to explain things, just saying the graph might be okay on this one because they did give you a graph of f, but we typically always want to name the function. So be careful with that. But why does that have to be negative?
Because g is decreased, so derivative is negative. The derivative of g is.
So you're breaking up just a little bit, but yes, everything you said was great. So g is we want g to be decreasing, means the slope being negative, also meaning that the first derivative could be negative when we look at it, and f of x is the first derivative of g. So where it is negative, aka where it's below the x-axis. So our only choices are things from -2 to -1 and 1 to 2. But then they want it to be concave up. So we know that the second derivative has to be positive. I know you guys know that. So we'd have to be careful here. Looking at this graph, how do I get to the second derivative of g?
It's just
The slope of f.
Okay, the slope of f has to be,
Increasing.
so careful, slope has to be positive. The graph has to be increasing. Okay. Ooh, they tried to trick you. They are not nice. This actually becomes a much more difficult question than I had originally thought. So that's normally true. So from easily 1.7 to 2 works. So if this was not a multiple choice question, they're definitely trying to trick you. So let's see. Where would, so we want that to be,
How?
because see how your integral starts from 0 to x? If I go backwards, then it flips all the values around and becomes negative.
Oh.
So technically, I believe the answer choice um, of negative 0.7 to negative 1 might also be a correct answer. Or negative 1, no, negative 0.7.
Yeah, that's what I put.
Because that
But
is concave up.
apparently not.
Well, and the question is, would it be concave up? Because it's definitely decreasing at that point. But I think there should be more than one answer.
Because it's backwards, that's negative area. So as you go to 0, the area is increasing, not decreasing.
Okay, I see what you're saying.
How is it decreasing?
You have to think about the whole thing of it's backwards. So as you move from 0 to x is kind of the question. It would take a very crafty question to get this correct backwards. But they will have you do things backwards. So don't forget that. So because I'm going from 0, let's say I have my intervals from like negative 1 to x, or yeah, 0 to negative 1. Remember, that's going backwards. So whatever you would normally have for that area, the value is actually negated. So you would normally say, oh, the area from negative 1 to 0 is a positive area. However, because how they have defined the function, that'll actually get you a negative answer. Because you're going from 0 to negative 1, not negative 1 to 0. I still feel like there would be a second answer going backwards. No, I think no matter what you do, that value is always increasing. No? From negative 2 to negative 1 in there, the value would be decreased. I think there's a second answer. They just don't give it. So there is a second answer. It just happens to be in the interval from negative 2 to negative 1. They just don't give you that option choice, so that's why the answer has to be 1.7 to 2. I want to say the answer of negative 2 to negative 1.7 actually works as well. Because the decreasing and then... maybe either that or negative 1.7 to negative 1. I have to think about it more, but it's not worth it. So the answer choice does work for sure. There is a second answer choice, I believe. They just don't give you the options of picking it, so they weren't that mean. But does everybody understand why the answer choice of D is correct, though? That's the more important thing than me playing around.
Yeah.
Okay. We have time to start B. Question 1 shouldn't have been too bad. Automatically right off the start setup of that question. What kind of question is that? Let's see if we remember. Oh, come on. Somebody please remember that kind of question.
FTC, is that what you're...
Fundamental theorem of calculus.
FTC.
Thank you. I was going to cry. Like, legit, I might have started crying. We had so many of these problems last year, and I yelled at you guys so much for FTC. But yeah, that's FTC, like, hands down. How do we know it's an FTC? What's the way that we know that again?
They
F
give
of 1
you.
equals 2.
So, Ivy, go ahead and finish your statement.
I was gonna say they give you f of 1 and ask for f of 4. So you have 2 points and a slope.
So our fundamental theorem for this kind of question would be like that. remember for FTC they will give you one and then ask you for another one. So they gave us the f of 1, they're asking us for 4. You can change this to primes and capital F's, it doesn't really matter. So usually they end up giving you the function, so you put this into the whole thing, goes into the calculator. If I could spell calculator, that would be great. So you put that part in the calculator to figure it out, and they're going to give you one of those. So they give you one of them and you find the other one. So at this point they gave us that. So you put the integral in your calculator, they gave us the -2, and that'll be f of, what, 4? I think it was, not f of x. So number equals that. So whatever that comes in from the calculator, and then you do that. That will definitely somehow be on the exam. There's almost no way I could see them not putting that on the exam for both AB and BC, some point, somewhere. Okay. Remember, do not try to do anything by hand on a calculator question. Speaking of which, I guess as we talk, they have said that this year, remember, you can use a calculator and everything. They've said you don't need a calculator. So remember to leave things unsimplified and stuff like that. You can put them in the calculator, but please be careful when doing that. You don't want to lose points for that, especially this year. But everything should be able to be calculated without the use of a graphing calculator. Select values of twice differentiable functions are given. Okay, so on number 2, the hard part here is figuring out you will need to take your antiderivative. Let's see, what would... oh, no, you won't. It's... Yeah, oh. What on earth is... Do I use sub, I guess? Yeah, you'd have to do like a U sub type idea and get the G and G prime out of there. That is a very strange problem. I assume I probably need to do that, don't I?
Yeah.
Okay, so...
Well, it says U would be 2G plus 3.
Yeah, it'll be the inside. That's the only way you're getting rid of it, because at first I was going to say, oh, just take the antiderivative, make compensations, but at the same time, we don't know the derivative of tangent squared, or the antiderivative of tangent squared. So you would have to do u is equal to 2g of x plus 3, so your du will be 2g prime of x, so 2d, not 2, 1/2. So 1/2 du is equal to g prime of x. So then when you go to put it in your integral, we'll have to do that in a second. We'll get 1/2 du for the g prime out front, and then you get arctan of u. Bring the 1/2 out front, so you get 1/2 integral arctan. It wasn't arctan, it was just tangent, right? I don't know why I wrote arctan. Tangent squared of u. So 1/2 tan squared of u du. The problem... What?
I think it is arctan.
Oh, it is
in the
arctan
top
squared.
one.
Okay, yeah, we definitely don't know the antiderivative of arctan squared. Heck, we don't even know the real derivative of arctan without doing a whole lot of work. So at that point, the problem is, what are our bounds? And that's where you do have to be careful. Your bounds have to be u's. You can't use the same values of 0 and 4. So we have to figure out what 0 and 4 are when we plug them into the top u substitution up there. So u of 0 will be 2g of 0 plus 3. And then u of 4 will be equal to 2g of 4 plus 3. That is not the easiest of substitutions or things to figure out, to be honest. I can see a lot of people looking at that one going, what? Because at first I did. And apparently those values are what, 5 and negative 2? Okay. And we will stop there for today.